Hello, year four. So our first lesson this week is thinking about dividing two-digit numbers by single digits. Both the lessons this week are about dividing, but we're just going to break it down slightly so that we can have a look at the skills needed in order to carry out division, whether it's with two digits or three digits. Okay, for our first example, we're going to use our place value grid to try and help us solve a division sum. The first one we're doing is 93 divided by 3. I'm not going to explain to begin with, I just want you to have a go, and then I'll go through the explanation of how this particular model works, and then you can try it yourself. Pause now. Okay, so this model uses the framework of a place value chart, which we've got here, our 10 column here and our 1 column here. And actually the first step to do is to split your your place value grid with the number of rows of the number you're dividing by. So I have 3 rows because I'm dividing by 3. Then I equally share my 10s and my 1s into those 3 rows. So the first thing is I do my 9 10s. We always start at the top, work our way down. I'll tell you why later. But we put that 9 in. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember, when we're dividing, they have to be even. So if it wasn't, you weren't going to have to fill it out. You weren't going to have 1 in all of them. You wouldn't be able to share them. It would have to do something else with them. Then I can do my 1s, and I go 1, 2, 3. So how to find the answer from this? And the way to do it is you look at your rows, and you just look at one of the rows and read across how many 10s and how many 1s you have, and that gives you your answer. So in this case, the amount of 10s we have is 3, and the amount of 1s we have is 1. So 93 divided by 3, the answer is 31. Okay, so here's another example. It's 49 divided by 4. I've shown you the place value grid, and I've already split it into 4 equal rows. Have a go, and then I'll explain the answer. Pause now. Okay, so when looking at this, we do the same things we did before, and the first thing we do is we are going to evenly share the 10s out. So I put my 10 in my 4 10s into each individual one. That's my 4s, nice equally shared. Then I'm going to share my 1s into the 4 rows. So I put 2 in here, 2 in here, 2 in here, 2 in here. Now the problem is that's only 8. The next one we'd put in, I wouldn't be able to fill in and evenly share between all 4 rows. So what I'm left with is 1 on its own. And the way in which we say this is we give our answer. Remember, we're only looking, in this case, in 1 row. So we look across in 1 row, our answer being, in that case, 1 10 and 2 1s. We say remainder, and then we just say how many we have left over. In this case, we have just the 1 left over. So our answer would be 12 remainder 1. Like that. There are lots of other ways to write remainder 1. First off, you can write it as a fraction, but it has to be over what you have here. So whatever you're dividing by, you say you have 1 of 4, so it'd be 1 over 4, so the same as a quarter. If you know that, you could also exchange it into decimals if you knew that a quarter was the same as 0.25. One other thing that we need to be aware of when using this model to help us is what happens when we have too many 10s that we can't split into here. It doesn't go as a remainder straight away. What you do is exchange that 10 into the 1s. So you have whatever your 1s is that you're putting into the 1s column, and the additional 10s are left over. This way, your remainders should only ever be ones, and they can never be over how much you're dividing by. So in this case, if I'm dividing by 4, my remainder could be 1, 2, or 3. If it ever got to 4, that would be another column that I could fill in each of our rows. So our remainder can only be the numbers lower than what we're dividing by. Again, if you have too many 10s, exchange them for 1s. This can mean that you can be actually splitting lots and lots and lots of 1s, and that can take a long time. And this is why this model, although works very well, can be very slow. Okay, so this is another model, and it uses the whole model to try and help us out. And the way in which it goes about it is it splits it into numbers that we know are divisible by 4 in this case, or whatever we are dividing by. What it does is that it takes the number that we're dividing by, so in this case 68, and splits it into 2 parts, both divisible by 4. So 60 is divisible by 4 because both 40 and 20, and they go together to make 60, are divisible by 4, and 8 is divisible by 4. Then after you split them into your parts, you divide by whatever you're dividing it by, 4 in this case. So 60 divided by 4 is 15, and 8 divided by 4 is 2. You add the 2 answers together, and when you add the 2 together, so these 2 are added together, that again gives you your answer. Another thing to remember with this particular model, using the part-whole model, that actually we can split this into lots of different ways. So we could split it into 60 and 8, or we can split it into parts that we know are divisible by 4. So the first part I could make as 40. I know that 40 is divisible by 4, so 40 divided by 4 is 10. Then I look at what I've got left over, and what I have left over is 28. I know 28 is also in the 4 times table, so I can put 28 there, divide it by 4, get my answer of 7. Once again, I can add those 2 together, and I get my answer. So as long as the 2 parts still make the whole, it doesn't matter how you divide it. So you could do multiple parts that allow you to still do your division nice and straightforward, using your division facts you know from your times tables. This way is quite useful because it can also be used in any situation. One thing to note is that if, for example, the number here, after splitting down, so say it was 69 instead of 68, I could split 40 off, and I know that's in my 4 times table. I can still split 28 off, but that would leave me with 1 left over, which I know is not divisible by 4, and that's where our remainder 1 comes from. Have a go at these 2, then we'll talk it through, and then I'll give you the answers and the way we go about it. Have a go, pause now. Okay, so the first thing we've done, I've already split the answers into parts, and I've split 42, I split it into 30 and 12, because I know both of these 2 numbers are divisible by 3. I can divide 30 by 3, which is 10, and I can divide 12 by 3, which is 4. And once again, we just add the 2 parts together, and that gives us our answer of 14. And this is an example of when we might split it so that we don't split it just into 10s and 1s, because if we were split into just 10s and 1s, we'd be left with bits over. We can't divide 40 by 3, and 2 is not divisible by 3. So if we were to do that, this wouldn't work. So use your knowledge of your times tables to help you. Now we go back over to the other side, and we've got 72 divided by 5. Now, this is an example of where we might have to use remainders, because I could split 70 off. I split 70 off, I can divide 70 by 5 and use that. Or if I wanted to make my life slightly easier, I could 70, but instead split that 70 into 50 and 20 and have 2 left over. And it's important that I put that 2 here as a separate part. And the reason for that is that this bit is not divisible by 5. So this is going to be our remainder. Both of these 2 parts are divisible by 5. So we do our division. We divide 50 by 5 and get 10. And we divide 20 by 5 and get 4. We add our 2 parts together. That gives us our answer of 14, but we have a remainder of this 2 here, which is not divisible by 5. So our answer would be 14 remainder. Here are your questions for this lesson. Question 1 is just practicing using either model you like, 2 digits by 1 digit. Have a go just to practice the skill. And then question 2 is a little bit of problem solving for you and where you might be pushed in your understanding. Thank you, and I'll see you in the next lesson.